Hello everyone and welcome to Natural Resources Canada's e-training module on optimizing the energy performance of existing buildings. This course has been adapted from the U.S. Department of Energy's Federal Energy Management Program training material on optimizing the energy performance of existing buildings. This training is being delivered through the Natural Resources Canada Greening Government Services to help federal departments and agencies plan and implement projects that reduce the energy use and greenhouse gas emissions in their buildings, laboratories, other facilities, and vehicle fleets. Over the years, Natural Resources Canada has been successfully developing comprehensive methodologies, practices, and tools to reduce energy consumption and greenhouse gas emissions for the private and public sectors, including the federal government. Since 1991, NRCan has provided enhanced technical support to Government of Canada organizations seeking ambitious greenhouse gas emission reduction actions from their building and fleet operations. This training will support federal organizations to meet their commitments and lead by example. Federal facilities have committed to reducing emissions from their operations by 40% below 2005 levels by 2025 and by 90% by 2050. As outlined in the 2020 Greening Government Strategy. It is important to note that federal buildings represent almost 90% of the government's greenhouse gas emissions. This initiative also supports the commitment by Canada's federal, provincial, and territorial First Ministers to scale up efforts to transition to highly efficient buildings and zero-emission vehicle fleets as specified in the Pan-Canadian Framework on Clean Growth and Climate Change. The ultimate objective of this training course is to present the incremental steps to optimizing the energy performance of existing buildings. This course will flow in a way that introduces the 4 guiding principles that should be followed sequentially on the journey to optimizing the energy performance of existing buildings. Each guiding principle will be accompanied by best practices and associated metrics to provide guidance on actions that can be taken to meet the guiding principle in question. Certain guiding principles are related to federal commitment that have been made as part of the Greening Government Strategy. These commitments will be identified as applicable. The 4 guiding principles are metering, benchmarking, energy efficiency, and renewable and clean energy. The first guiding principle relates to metering. Metering is the practice of recording the amount of energy being consumed within a facility. While most services to a building or campus are metered for billing purposes, there is an opportunity to further understand how energy is consumed in a building by installing additional meters on specific components. By metering buildings and services individually rather than as a group, energy managers can more easily identify opportunities for improvement. Best practices state that facilities should install building-level meters for electricity, natural gas, and steam at a minimum. Different types of meters are available to meet the required level of detail. The Greening Government Strategy states that all departments should meter energy use and report energy use intensity by 2022 for government-owned buildings of no less than 1,000 square meters. With meters or tracking energy performance over time, the facility team can proceed with benchmarking. This is the second guiding principle for optimizing energy performance in existing buildings. The process of establishing a baseline of energy performance is the starting point for benchmarking. Once a building produces information about how energy is consumed on site, the facility team can use this information to prioritize improvement projects. The energy efficiency of a building can be calculated using a metric called energy use intensity, which is expressed in kilowatts per square meter. This concept is used to measure how efficiently energy is being used within a building and allows for comparison to other buildings of similar size and operation. Benchmarking typically aims to improve the energy use intensity of a building. There are 2 common software tools that can be used to facilitate the benchmarking process in the federal sector. Energy Star Portfolio Manager and RETScreen Expert are the leading tool for tracking and comparing building energy use over time. Benchmarking best practices state that facility managers should set energy performance benchmarks annually, preferably using Portfolio Manager or RETScreen to compare the actual performance against the established benchmark. This involves regularly monitoring building energy performance against historical performance and peer buildings. The Government of Canada is committed to ensuring accountability for the government's environmental performance and will adhere to this commitment using the principles of transparency and open data. Facilities can demonstrate proper implementation using documentation from Energy Star Portfolio Manager or RETScreen. Property types that are not eligible for an Energy Star score can still generate reports showing benchmarking properties and trends of energy use over time. Facilities that choose not to use Portfolio Manager can set benchmarks and compare their energy performance using other means such as utility billing data or internal energy reports. Energy Star Portfolio Manager is a free, interactive energy management tool that allows users to track, assess, and benchmark energy and water consumption for all facility types across entire building portfolios. Portfolio Manager has a standardized metric for comparing whole building energy performance to similar buildings of specific ratable types. Another tool that can be used for benchmarking purposes is RETScreen Expert. Developed by the Government of Canada, RETScreen Expert is a software for energy efficiency and renewable energy project feasibility analysis as well as ongoing energy analysis. This tool has many functions and can be used to perform portfolio-wide analysis, collect information on a facility, perform benchmarking analysis, track energy and greenhouse gas emissions, and for general performance analysis. This tool is used widely throughout government and industry. Some of the key users include 3M, CRH Canada, Oxford Properties, Canadian Tire, the Coalition of Ontario Universities, National Defence, Public Services and Procurement Canada, and Natural Resources Canada. After setting an energy performance benchmark, the next step is to develop and evaluate options for improving the energy efficiency of a building. There are 3 best practices to follow when looking to improve energy efficiency as shown on the slide. Implement these best practices as applicable depending on the age of the building, the state of the current operating conditions, and the availability of information about energy-using systems. When there is little information available on current operating conditions, the first best practice is to conduct a building-wide energy audit to identify the major energy users and uncover opportunities for improvement. If the building's energy performance and operating conditions are known, it might be appropriate to implement best practice number 2, which relates to recommissioning. In fact, best practice recommends performing recommissioning every 5 years to ensure and maintain optimal building performance. The final best practice is to ensure that energy-efficient products and equipment are being procured and installed as required. When we speak of energy efficiency, there are 2 key performance indicators that facilities can use to gauge success. The first option is to obtain an Energy Star score of 75 or higher using Portfolio Manager. The Energy Star score is calculated using building characteristics and consumption information to provide an external reference that helps energy managers assess how efficiently a building uses energy relative to similar buildings. A score of 75 or higher indicates that your building is in the top 25 percentile of performance in comparison to buildings of the same operation type. Reports from Portfolio Manager can be used to demonstrate proper implementation in this area. In addition, certain eligible commercial and institutional buildings that achieve a score of 75 or higher can apply for an Energy Star label through NRCan's Energy Star Building Certification Program. We will go into more detail about Energy Star ratings in the following slides. Energy Star scores range between 1 and 100. Buildings that receive a low score may be great candidates for major energy efficiency upgrades. This may include buildings that have been targeted for energy improvements and can show significant savings following the installation of new equipment. Scores between 25 and 50 may need a combination of building improvements and minor adjustments. Building scores between 50 and 75 can benefit from lighting and building control upgrades or recommissioning. Recommissioning is a periodic, recurring re-optimization process that is carried out after 3 to 5 years. Buildings over 75 are performing in the top percentile. Further improvements can be achieved through tenant education, ongoing commissioning, and initiation of a plug load reduction strategy. Ongoing commissioning is a continuous process that often involves data analytics using fault detection software. While all facilities can track and assess energy, greenhouse gas emissions, and water use by using Energy Star Portfolio Manager, currently there are only 7 building types eligible to receive an Energy Star score. They would include ice rinks, K-12 schools, medical offices, hospitals, supermarkets, office buildings, and senior care communities. NRCan is developing new scores on a progressive basis, and your building type could be next. If a building is not eligible for an Energy Star score, it can still demonstrate superior energy efficiency by achieving the second key performance indicator, which is a 30% energy efficiency improvement over the current ASHRAE 90.1 standard. This option requires an energy simulation to determine the actual energy efficiency of the building. ASHRAE 90.1 is an American national standard that provides minimum requirements for energy-efficient designs for buildings except for low-rise residential buildings. For existing buildings, energy managers can use various software, such as CanQuest, to determine how it compares to the latest 90.1 standard. For new buildings, facility managers should review the design and commissioning records on file. Has an energy analysis been completed? And if so, what were the results? For buildings completing major renovations, facility managers should inquire with their energy service provider to determine if savings have already been calculated. A building can demonstrate success in this area using reports from the energy simulation or another form of energy use model that confirms a 30% better efficiency than ASHRAE 90.1. A good example of implementing this principle is through improving efficiency in plug loads. Energy consumed by plug loads is one of the largest and fastest growing end uses in the commercial building sector. Examining opportunities to reduce plug loads may reveal low-cost options for reducing energy consumption. Break rooms, office electronics, and data centers are prime candidates to consider when looking to reduce plug loads. Reducing these loads will help these facilities meet their energy efficiency targets. The next guiding principle pertains to renewable and clean energy. The best practice states the facilities should evaluate two options for obtaining access to renewable and clean energy. The first option is to implement an on-site renewable energy project when it is shown to be life cycle cost-effective. If this option is not feasible or cost-effective, the next option is to engage in the long-term procurement of renewable energy credits, or RECs. The recommended approach begins with a feasibility assessment for an on-site renewable energy project that can meet the requirements of all buildings. If this is not possible, the next step is to evaluate the feasibility of a building-specific installation where the electrical needs of a single building could be met using on-site renewable energy. When on-site renewable energy projects are not cost-effective, buildings may resort to the purchase of renewable energy credits to fulfill this guiding principle. Clean energy refers to both renewable electric energy and alternative energy. Renewable electric energy includes energy produced by solar, wind, biomass, landfill gas, ocean, including tidal, wave, current, and thermal, geothermal, microturbines, municipal solid waste, or new hydroelectric generation capacity achieved from increased efficiency or additions of new capacity at an existing hydroelectric project. Alternative energy includes energy generated from technologies and approaches that advance renewable heat sources, including solar thermal, biomass, geothermal, waste heat, combined heat and power, small modular nuclear reactor technologies, and fuel cell energy systems, where active capture and storage of carbon dioxide emissions associated with that energy generation is verified. One example of a federal government building that is raising the bar regarding renewable and clean energy is the CanMet Energy Laboratory located in Varennes, Quebec. This facility conducts applied research aiming to facilitate the integration of distributed renewable energy sources to the electricity grid and to net zero energy buildings in partnership with industry and utilities. The building itself is equipped with 3 renewable energy systems. The first is a solar wall that captures thermal energy from the sun and uses it to preheat the fresh air intake. At its peak performance, this system was shown to generate an estimated 10,000 kilowatt-hours of thermal energy. The second uses a solar photovoltaic system with an estimated generation capacity of 41,500 kilowatt-hours per year. This system of 162 photovoltaic modules is split into 7 individual circuits to allow for testing of different inverter technologies. The third system includes an innovative solar thermal heating and cooling system which uses a parabolic solar collector with an ejector compressor to generate heating or cooling loads for use inside the building. This technology is currently being tested and optimized. As outlined in the Greening Government Strategy, Canada is committed to using 100% clean energy by 2025 by producing or purchasing megawatt-hours of renewable electricity equivalent to that produced by the high-carbon portion of the electricity grid. Departments can demonstrate proper implementation using various documentation, which can take the form of utility records, agreements, contracts, or photos of existing renewable energy generation projects. Documentation showing that renewable energy credits have been acquired can also be used. NRCan offers tools to help evaluate the potential for renewable and alternative energy. These analysis products provide energy managers with information needed to perform their own pre-screening. RedScreen is a clean energy management software for energy efficiency, renewable energy, and cogeneration project feasibility analysis, as well as ongoing energy performance analysis. PB Perform Mod is a software tool that predicts the electricity output of a photovoltaic system, detects faults, and evaluates system performance. Enercan has developed a database of photovoltaic potential and insolation. This database provides estimates of the electricity that can be generated by photovoltaic arrays for over 3,500 municipalities in Canada. Enercan also has a web page dedicated to highlighting renewable and clean energy projects in Canada. Visit the website shown to explore Canadian success stories. This course has provided an overview of the guiding principles and best practices related to optimizing energy performance of existing buildings. The 4 guiding principles are metering, benchmarking, energy efficiency, and renewable and clean energy. These guiding principles form the basis of the approach that should be taken when looking to optimize energy performance. We also learned about software tools like Energy Star Portfolio Manager and RedScreen and how they can assist us on our journey to optimizing energy performance. Together, we can lead by example and create a more sustainable future. Enercan and other federal organizations provide valuable resources, guidance, and training in areas related to energy performance optimization. Examples of available resources include the Pan-Canadian Framework on Clean Growth and Climate Change, the Federal Sustainable Development Strategy, the Greening Government Strategy, and Enercan's Energy Management Best Practices Guide for Commercial and Institutional Buildings. These resources can be used to learn more about active federal commitments related to climate change and strategies to meet these objectives. Lastly, if you have any questions about optimizing the energy performance of existing buildings or are interested in other training opportunities, do not hesitate to get in contact with the Office of Energy Efficiency using the contact information provided. Our email address is enercan.greeninggovernment-governmentvert@rncan@canada.ca. Our website can be found at www.enercan.gc.ca/greening-government. Thank you for participating. Now we will have some quiz questions to test what we've learned. Question 1. Which of the 4 guiding principles relates to improving the energy performance of specific building components or systems? A. Energy efficiency. B. Renewable and clean energy. C. Metering. D. Benchmarking. The correct answer is A. Energy efficiency. Question 2. What is the minimum energy performance score required for a building to be eligible for the Energy Star certification? A. 55, B. 65, C. 75, or D. 85. The correct answer is C. A minimum Energy Star score of 75 is required. Question 3. Which of the following are key performance indicators related to the energy efficiency of a building? A. Receive an Energy Star score of 75 or higher. B. Energy use is 30% higher than the fiscal year 2003 energy use baseline. C. Energy efficiency is 30% better than the current ASHRAE 90.1 standard. D. A and B. E, A, and C. The correct answer is E, A, and C. Question 4. Can energy modeling be used to demonstrate improved energy efficiency beyond the current ASHRAE 90.1 standard? A. Yes. B. No. The correct answer is A. Yes. Question 5. The purchase of renewable energy credits can be used to meet the guiding principles related to renewable and clean energy. A. Yes. B. No. The correct answer is A. Yes. Question 6. A whole building energy audit is the starting point for meeting the guiding principle related to benchmarking. A. True. B. False. The correct answer is B. False. An energy audit is associated with energy efficiency. Question 7. A renewable energy system that is not grid connected and serves only one specific building is not recommended under the guiding principle related to renewable and clean energy. A. True. B. False. The correct answer is B. False. Question 8. Which of the guiding principles should be taken on first in your journey to optimizing the energy performance of an existing building? A. Metering. B. Energy efficiency. C. Benchmarking. D. Renewable and clean energy. The correct answer is A. Metering. Metering is the first step to optimizing energy performance as it allows you to ensure the baseline energy consumption. Question 9. What is the national greenhouse gas reduction target established in the Greening Government Strategy? A. 50% below 2005 levels by 2030 and by 60% by 2050. B. 40% below 2005 levels by 2025 and by 90% by 2050. C. 20% below 2005 levels by 2030 and by 70% by 2050. The correct answer is B. 40% below 2005 levels by 2025 and by 90% by 2050. Question 10. Which guiding principle is related to the best practice of performing recommissioning on building systems to ensure they are operating optimally? A. Energy efficiency. B. Renewable and clean energy. C. Benchmarking. D. Metering. The correct answer is A. Energy efficiency. If you have any questions about optimizing the energy performance of existing buildings, do not hesitate to get in contact with the Office of Energy Efficiency using the contact information provided. Our email address is nrcan.greeninggovernment-vert.rncan@canada.ca. Our website can be found at nrcan.gc.ca/greeninggovernment. Thanks again for your participation.